The next article is the strain load cell, or that the pressure cell. That means the load cell is the force transducer. It converts a force such as tension, compressions, pressures, or that the torque into and that the electrical signal that can be measured and standardized. As the force applied to the load cell increases, the electrical signal changes the proportionally. The most common types of the load cell used are that the strain gauge, pneumatic, and that the hydraulic. This figure shows the load cell, strain gauge load cell. The load cell is used to weight extremely heavy loads. A length of bar, usually steel, is used as an active element, and the weight of the load applies the particular stress to the bar. The amount of the strain in which the result in that the bar for that the different values and that the applied stress is determined. So that the strain may be the used for that the direct measure and to the stress causing. The load cell shows in that the good example for that the strain gauge is weighing operations. The strain gauge load cells are the kind most often from that the industrial setting. It is ideal as the highly accurate, versatile, and that the cost effective. Structurally, a load cell has a metal body to which strain gauge have been the secured. That means the body is usually made of from that the aluminum, alloy steel, or that the stainless steel, which makes it very sturdy but is also minimally elastic. That means this elasticity gives rise to the term in that the spring element, that is the referring to that the body of the load cell. When force is exerted on that the load cell, the spring element is slightly deformed. That means the unless the overloaded is always returned to that the original shape. As a spring element deforms, the strain gauge also changes the shape. The resulting alternation to that the resistance in the strain gauge can be measured as the voltage. The change in voltage is proportional to that the amount of the force to that the cells. Thus, the amount of the force can be calculated from that the load cells output. That means as per the stress is applied along the direction of the S. That means shown by the arrow in that the figure. The steel bar experience a compressions along that the axis, and that the expansion of that the along that x and the y axis. As a result, gauge A experience a decreases in that the resistance, while the gauge B undergoes that the increasing in resistance. When these two gauge and the gauge on that the two remaining sides of that the steels are connected to the bridge circuit, 4 times of the sensitivity of a simple gauge is that the obtained, and to make this load cell sensitive to very small value of applied stress as well as extremely heavy loads. That means a strain gauge is constructed of that the very fine wire, or that the foil, or that the setup from that the grid pattern, and the attached to the flexible backing. When the shape is strain gauge is alternated change, electrical resistance occur. The wire of the foil in that the strain gauge arranged in that the way when the force is applied one direction, and that the linear changes of that the result tension force stretched of that the strain gauge, causing it to that the thinner and longer resistance increases that the resistance. That means the compression force does not opposite. The strain gauge is the compressions becomes thicker and shorter, and the resistance is decreases. The strain gauge is attached to that the flexible blanking, whereas the flexible blanking, enabling to the easily apply to that the load cells. That means the mirroring of that the minute change to be the measured. Since the change in the resistance measured by the single strain gauge is extremely small, and it is difficult to the accurately measure for that the changes. That means the increasing the number of the strain gauge applied connectivity magnifies the small changes into the sometimes the more measurable. A set of 4 strain gauge sets is the specific circuit is application of that the Viston bridge. In that the Viston bridge used for that the cells, the Viston bridge is configuration of that the 4 balanced resistor with a known as the excitation voltage applied that. That means the excitation voltage is also known as the constant and the output voltage. That means the excitation voltage is constant and that the output voltage is versatile. That means the depending upon the shape of the strain gauge. If the all resistors are balanced, meaning that then the 0, and if the resistance even one resistor changes, then will likewise the change. That means the change in can be the measured interrupted using that the Ohm's law. In that the Ohm's law states that the current measured in that the amperes running through that the conductor between the 2 points. In that the first is the directly proportional to that the voltage, and second one is the across proportional to that the resistance. That means the measured in that the ohm resistance measured in that the ohms, it is introduced by that the constant in this that the relationship, while independent of that the current. That means the Ohm's law is expressed when the applied the 4 legs of the Viston bridge circuit as the resulting for that the load cells. The resistors are replaced with the strain gauge and the arranged and that the alternating tensions and that the compressions formations. When the force is exerted on that the load cell, the structure and that the resistance of the strain gauge changes and it measured. That means the resulting data can be easily determined using for that the common type of that the load cell. In that the common type of the load cell, there are the several types of the strain gauge load cells. The first is the single point of the load cells. In that the single point of the load cells used for that the small to medium platform scales with the platform size, and that the size is the 200 into 200 mm up to the 1200 into the 1200 mm. The planar beam load cells used for that the low profile solution, whereas the space is limited. Then next is the bending beam load cells. In that the bending beam load cells used for that the pallet, platform and that the small hopper scale. Then next is the shear beam load cells. The shear beam load cells used for that the low profile scale and the processor application. For that the available capacities from the 100 kg up to the 50 feet. Then next the dual shear beam of the load cells. In that the dual shear beam of the load cells used in that the trunk scales, that means the tank and the hopper application. The next is the S type of the load cells. S type of the load cells used for that the tensions of the applications, where you will find the static and the dynamic loads. The next is the compressions load cells. In that the compression load cells used in the trunk scales, large platform scale and the hopper scales. The next is the ring torsions load cells. In that the ring torsions load cell used in that the high accuracy hoppers, whereas the spoke type of the load cells, in that the spoke type of the load cell used in the low profile high precision applications, whereas the onboard load cells, in that the onboard load cells is used for that the onboard weighing system on that the trucks, tractors and that the other vehicles, whereas the load pins in that the load pins is used for that the application, for that the measuring dynamic and that the static hosting forces.